Today we are going to talk about scalars and vectors. Any quantity in physics can be considered as a scalar quantity or a vector quantity. What is the difference between both of them? Scalars quantity are magnitude only. What is the meaning of magnitude? Any numerical value. So if I say 5 meters only without mentioning direction, so that would be a scalar quantity. 10 meters, a scalar quantity. 100 meters, a scalar quantity. On the other hand, if we're talking about vectors, so we need to mention direction. So I'm gonna say 10 meters as the magnitude plus east, for example, up, down, left, right, north, whatever the direction it would be. But at the end, I need to mention the direction to understand the quantity that I have. For example, if I ask you about your age, you can say, okay, I am 16 years old. So you mentioned only a number, 16 years old, and I understand your age, right? You didn't mention any other thing right there. You didn't say north, east. So I got it from only the numerical value. So age can be considered as a scalar quantity. Also, if I'm asking you about time, okay, what is the time right now? You're gonna say, okay, it's 2 o'clock. So I got the value right there. It's 2. Okay, so this would be identified by only knowing the numerical value that we have, the magnitude that we have, without mentioning direction. It would be a complete info for me. Okay, so age and time can be considered as a scalar quantity. Let's start by speed. Speed is also a scalar quantity. So once you find in the problem, I'm saying 22 meters per second, for example, without mentioning any direction right there, this directly would gonna be the speed. On the other hand, if I say velocity, so I would say in the problem, the car is moving 22 meters per second to the east, or to the north, or to the left, or to the right, whatever the direction it would be. So this is the first part by identifying speed and velocity. Let's go to the second one by the distance and displacement also. Okay, so let's talk first about distance. Distance, we are gonna sum up all the numerical values we're gonna have in the problem. So you are right now in your home and you are gonna go to your school. The distance between your home and your school would be 1,000 meters. So you're gonna go at the beginning of the day to your school, and at the end you're gonna go back to your home at the end of the day. So we are gonna say 1,000 meters in the morning when you are going to school, plus the other 1,000 when you're gonna go back to your home at the end of the day. So the total distance covered by you on this day would be 2,000 meter. This is how we are calculating distance. We are not taking the direction in consideration. But on the other hand, for displacement, okay, this one would be a little bit different. The boy moved 1,000 meters to the east, 1,000 meter east, and after that he moved 1,000 meter to the west, which would be a negative value right there. So plus negative 1,000 meters. So at the end of the day, how much 1,000 plus negative 1,000? It would be 0 meters covered by this boy. So the difference between distance and displacement is the direction. In the displacement, whenever you go to your starting point again, whatever you do regarding the day, once you go back to your starting point again, this would be the displacement equals to 0. Also, we can consider force as a vector quantity. For example, if I say to you, push this box a little bit, so you are gonna ask me, where should I push it? Beside the window, beside the door, outside the room. So I need to mention, okay, push this box with 10 newtons to the left. So to complete the info for you, to make you understand what I'm saying, I need to mention the direction that you are gonna push the box to. After that, we are gonna have mass. Mass is considering as a scalar quantity. Wherever you go, the mass would be the same value, let's say 10 kilograms. If you go to the moon, to the earth, to Neptune, to Jupiter, it would be 10 kilograms. On the other hand, we're going to have the weight, which is changing regarding the position. So the weight of an object on earth can be 10 newtons, but when you go to the moon, it would be a different value. But when you go to Mars, it would be a different value. So it's always changing regarding the place that you are going to go to. Acceleration also can be considered as a vector quantity that we need a direction to identify it. So at the end, as a quick recap, distance is vectors are different than scalars. One of them, the scalars, can be identified only by knowing the magnitude, but vector, you need to mention magnitude plus the direction to make it a complete info to use the quantity that we are talking about.